On the question of chess-playing programs, I only described the way I thought one ought to evaluate. One ought to first ask, is it an interesting question at the current moment of science to figure out how people play chess? The answer to that's probably no. It's not an interesting question at the current phase of our understanding of the mind. But let's assume for the sake of argument that it is an interesting question, so just for the sake of argument. Then we take a look at some program that, say, does as well as Kasparov or, Grandmaster, and we ask, does that program tell us anything about the way humans do it? And the answer to that is flat no. They're designed so as not to tell us anything about the way humans do it. The programs are designed to exploit the capacities of computers, which are very different than the capacities of humans. So they have deep search and fast, big memory and all that kind of stuff. So we therefore throw out the systems instantly, at least on scientific grounds, because they don't do anything. So they're studying what's probably a dumb question, and they're giving an answer which is totally useless. So what's the point? Well, as far as I can see, the only point is either advertising and getting research grants, or maybe taking the fun out of playing chess. If there's some other point, I don't know what it is. I've felt this for about 40 years, I should say, and I've never been able to convince anybody, so maybe I'm wrong. The general attitude remains the one that I quoted from Herbert Simon, that this is the sort of core, it's like Drosophila, it's the sort of fundamental question in the field. Unless, as far as I can see and have always felt, it's a totally pointless question, just a waste of time. Maybe something useful will come out on the side, like maybe by accident it'll have some spin-offs, like, maybe it'll help somebody figure out more complicated software ideas or something. Anything can always have side effects. But as a research program, it doesn't seem to me make any sense. If that's the core program of the field, then I think we have to just get rid of the field.
Okay, let me try to ask my possible question here then. In your talk about, in this talk, you've described the natural science methods and ways of doing things that are useful, but then obviously a lot of research money is going into these things which are apparently much less useful.
Useful isn't quite the point. Insightful, I think, is the thing. A lot of things are worth doing even though they're not useful because they give you understanding. Mm-hmm. Understanding is a value in itself. But these things don't even give you any understanding. All they do is maybe fool people or something like that.
So what I'm wondering is there a connection, in your opinion, or what do you think of the idea that there might be a connection between the kinds of things that get funded that lack real progress in science and the kinds of things that get funded in the economy and politics and so on?
Well, first of all, I don't regard this stuff as science. So, I don't know if that's obvious from what I was saying, but most of it doesn't seem to me science at all. It seems to me kind of hype, or maybe sort of badly organized engineering or something like that. But within real science, people make mistakes, but I think there's sort of reasonable interaction about what's the right thing to do on sort of a rational basis. There's self-advertising and power trips and so on and so forth, but when you move towards subjects that have more intellectual substance, you move towards more integrity. Not because the people have better genes, but because nature's a hard taskmaster and it doesn't allow you to fake. So the more you understand, the harder it is to fake. So you get more honesty, just kind of like that. In areas like, say, the economy and political decisions and so on, the stuff is usually for power interest. Doesn't have anything to do with only marginal things to do. It's kind of very low-order factors are things like human significance or anything like that, which again is pretty, not terribly surprising. If you just look at the institutional structures of the society, who's in a position to influence decisions, what their institutional roots are, well, sort of predict it, kind of on trivial assumptions.
Thank you very much. I'd like to close with this comment. If somebody makes a computer that can do the sort of analysis that you do, then I'll believe they've achieved something.
Don't forget, you can't design programs that do simple things like talking like a 2-year-old.
Hi. I wanted to raise a point with the chess-playing computer again. I think I would take issue with the fact, or with your opinion, that they're useless right now, or they don't tell us anything. I think I might be looking at it the wrong way. To say that a computer plays chess, but it doesn't model human thought, makes it useless. I don't
Pointless,
think so.
not useless. It would be useless even if it did model human thought. Maybe it would be interesting, but it would be useless if it modeled human thought. I'm suggesting it's not only useless, which is not necessarily a major criterion, but pointless.
But isn't it possible, if you look at it from a different viewpoint, to say, can we design a machine that can solve a problem within a limited domain that humans have difficulty with? In which case, I think a chess-playing computer does very well.
There's no point to designing programs that will solve, in general, that will solve problems within limited domains. There would only be, that's like an engineering problem. I'm saying, wouldn't it be useful to build a big machine? Well, not in itself. If you build a big machine that helps you make a bridge or something, yeah, then it was useful. But there was no point in building a big machine. And similarly, there's no point in constructing a program that will solve some arbitrary problem. That you can do, undoubtedly. For example, it's trivial. You can do it in your spare time if you've taken the first semester of computer science to write a program that'll run through some decision procedure for some simple part of mathematics. Sure. Yeah, you can do that. Once you learn the decision procedure and you learn how to program, you can do it. So what?
But maybe we're on taking steps towards something because...
Maybe, but that has to be shown. See, that's as if somebody came along and constructed some big machine and said, well, look at this big machine I constructed. Maybe it's a step towards something useful. Well, maybe, but I'll wait until I see.
Okay. Well, my point is that it seems kind of selfish to think that the only intelligence that we can have, or the only way we can solve very, very complex problems, is to use the human brain.
That's not true. Nobody believes that. You want to do weather forecasting, you're not going to use the human brain. You'll use all kind of statistical analysis of weather patterns, certainly using computers going way beyond the human brain. That's not anything to do with intelligence. That's, you want to solve a particular problem, you look for the best methods of doing it. For example, if you want to solve the decision problem for some elementary branch of mathematics, you'll use the decision procedure. That's not the way humans do it.
Right, right.
But that's because you have a goal. You want to solve that problem for whatever reason. So there's nothing to say that we only... See, the reason you try to understand what humans are doing is because you're interested in human beings.
Right.
If you're interested in human beings, you want to understand what humans are doing. That's tautological. If you're interested in solving a problem, you try to solve that problem. Okay, like if there was a purpose to playing chess, if there was a purpose to winning chess championships, that had some significance.
Well, I think chess is just a convenient setting to
do what?
To try algorithmic methods for doing quick searches.
There's zillions of possible algorithms. I mean, you make a slightly different game, you make up a different algorithm. There's no point to it. It's like building machines to do arbitrary tasks.
I think there is a point to it.
Well, what's the point?
The point is that we know if it's doing a good job or not.
No, but look, we can set up endless numbers of tasks, and we can design computer machines to do those tasks, and we can do it forever. There's no point.
Well,
there's no point to doing arbitrary tasks. Sometimes it may turn out that having tried an arbitrary task, you'll get something of some value, but you got to show that. So, like, suppose somebody said, "Look, I can build a machine which will, randomly interchange the chairs in this room, and I can do it very effectively." Well, maybe you can, maybe you can't. Is there any point in building it?
Well, I would argue that the point for chess-playing computers is that they experiment with, well, there are two, I think, theories right now. One is the chunking theory that Berliner uses, and there's the other one which just kills it with hardware.
Yeah. And neither theory has any intellectual interest or is related to any problem that we know about.
That's an opinion.
Well, if you can show that it is, you got to show it. Not just, here's the way I do it, therefore it's worth doing. If you have to say, look, here's the way I do it, and there's some reason why it's worth knowing the answer to that question. Tell me the reason. The reason can't be that it beats somebody at a chess game, because that's of no interest.
Well, what I'm saying is that maybe we could use these...
Maybe, but maybe the guy who designs the machine to randomize the chairs in the room will get something that's useful for some purpose too. Who knows?
Okay.
Just pick that at random. Pick anything else you like. Take any task you like, any crazy task you like. You could work on a machine that would do it as fast as possible. And, it's not inconceivable that as a result of having done that absurd thing, something useful might come out. But that's not the way you do science. Okay. Unless you can't think of anything to do for your thesis, then maybe you just pick something at random.
Well,
look, compare it with Drosophila. People in genetics didn't study Drosophila because, let's do something at random. They looked at Drosophila because they had particular questions to ask and they wanted to know the answers to them. And Drosophila happened to be the right system, the best system as far as I knew, to get those answers. Similarly, this guy who was looking at nematodes didn't just say, okay, I'll try to say something about nematodes. He picked them because they're the simplest organism with a wiring diagram worked out, and he wanted to know something about wiring diagrams. If you're doing rational inquiry, you're trying to understand something, and you organize your task, your research program, so it may lead you to understanding. You don't just do something in the hope that something will turn out.
Well, I don't think that's true right now.
Well, what is the goal?
Well, what we have in the world we have a huge environment, and we have to do, if you want to maybe compute it, is you have to be able to make searches from a wide variety of places. We have so many choices we can do. I can walk back to my chair, I can stand here, I could skip back to my chair. We have
So why not study that? I mean, I don't think there's any point to studying that either, because there's no
what
question.
I'm saying is there's a multitude of choices.
Yeah, but look, there's endless numbers of areas where you can set up problems with multitude of choices. Why pick this one? You only pick this one if you think you're going to learn something from it. See, if the model really is Drosophila, then let's do what the biologist did with Drosophila. Ask a question that's worth having an answer to, show that chess playing is the way to answer that question, then go ahead. But nobody's doing that.